Good evening, friends. Today we are going to discuss the topic, the basic of fundamental steps in digital image processing. So before going into the fundamental steps, first we have here a short review of what is an image and why we are calling it as a digital image. In general, an image is defined as a two-dimensional function which is represented by f of x comma y, where x comma y is a spatial coordinate or location, and where f is the intensity at that particular point. If x, y, and f all are said to be finite and discrete, we can say that image is to be a digital image. Okay, so the main things here is x, that is the spatial coordinates, and the intensity of the point f are all finite and discrete. We can say that the image as a digital image. So a digital image is going to consist of finite and discrete image elements, which is called as pixels. That is the basic unit of an image is going to be called as a pixel. So each pixel is going to have a location and intensity value. So in digital image processing, we are going to process the digital images by using digital computer. Okay, so the digital image processing is not a field which is used only for high-end applications. We can use the digital image processing at on many levels. So the next comes the classification of digital image processing. Okay, so that is we can categorize based on the levels of complexity. Okay, so the main steps or the main three types of this computerized processing can be classified as low level processing, mid level processing, and high level processing. In low level processing, we are going to involve the basic operations such as image pre-processing, image enhancement, image restoration, and image sharpening, etc. So here, the main characteristic of this low level processing is that both the inputs and outputs are going to be images. Okay, as the processing is going to happen at very low levels, here both the inputs and outputs are going to be the same type of file, that's image. Okay, so the next comes mid-level processing. Here, the mid-level processing involves tasks like image classification or object identification, image segmentation, etc. That is the next level of digital image processing. Here, uh, here the outputs and inputs can be a little bit different. Okay, so we know that the main characteristic of the low level processing is that the inputs are generally images, whereas here the outputs are attributes which associated with the image which are extracted from it. Okay, so the next comes high level processing. Okay, so here the high level processing involves making sense of an ensemble of any recognized objects and cognitive tasks associated with computer vision. Okay, so here the high level processing have more sense of complexity when compared to the previous two methods, low level processing and mid level processing. So the next, the components of image processing system. Okay, so the basic components of the image processing system in this diagram are shown. The first one, image display and computer, mass storage, hard copy device, image processing hardware, image processing software, and image sensors. Okay, so in general, an image processing system is a combination of different elements. Okay, what is it? So here, the image processing system is a combination of different types of elements which is going to be involved in processing of an image. It means by processing of an image by means of any digital device or digital computer. Okay, so for processing of the image, we can employ different computer algorithms to perform image processing on digital images. Okay, we are not going to use the same algorithm for the restoration, segmentation, and enhancement, etc. Okay, we are going to use different algorithms, different computer algorithms for performing different type of image processing on the digital images. Okay, so the basic, it's not basic, it means the major, the role of image processing is done by the first element called image sensors. Okay, so what is the use of image sensors? So the first thing we know, the use of sensor is to sense some physical quantity, temperature, humidity, motion, and so on. Okay, here image sensors denotes the function, that is sensing of intensity or an amplitude and coordinates and other features of the image and passes the result to the image processing hardware. So the thing is here is that the image sensor is to be included in the problem domain. Okay, so the next one, image processing soft hardware. Okay, so the first one is that we need some hardware to process the instructions obtained from the image sensors. Okay, so then the result is going to be passed on to the general purpose computer. Okay, so the computer using image processing system is a, is capable, it should be capable of doing major functions. Okay, for image processing. The next one, image processing software. You can see here the image processing software. The main use of it is to include all the mechanisms and algorithms that are used in image processing system. The next one, mass storage. Okay, the mass storage stores the pixels of the images during the processing. Okay, the next one, you can see the hard copy device here. Once the image is processed, then it is stored in the hard copy device. It can be a pen drive or it can be a CD or it can be any external ROM device. Okay, so the next comes image display. Okay, the image display is used to include the monitor or display screen that displays the processed images. Okay, the next one, for example, the network can also be one of the component of the image processing system because it is going to have the entire connection of all the above elements of the image processing system. Okay, so how we are going to start? So we are, the first thing, the image sensor is going to sense the intensity or amplitude or coordinates of the images, and then it is going to be passed to the image processing hardware. Okay, right? So here the image sensor is included in the problem domain. Okay, after passing the image to the hardware, it is going to process the instructions and then it is going to send to the computer. Okay, so after computer, what is going to happen? So here this software, this image processing software is going to include all the mechanisms and algorithms for image processing. The next come mass storage, which is used to store the pixels of the image. After the processing of image, then it is stored in the hard copy. Okay, next image display to display the processed images. And the last one is the network for connecting all the elements of the image processing system. Okay, so the next one, fundamental steps in digital image processing. Okay, the proper understanding of the steps will make us to explore more number of algorithms in the digital image processing. So hence we have to take a good understanding of the flow and what are the steps to be used in the digital image processing. Okay, here you can see the steps. We can see there are more number of steps in digital image processing. So here the first step starts with image acquisition. Okay. So in image acquisition, we are going to get the image in digital form. Okay. So we are going to get the image. How we are going to get the image? We can use some sensing materials like sensor strips or sensor arrays or some electromagnetic wave light sources. Okay, when this light source falls on an object, what happens? It is going to be get reflected or transmitted or captured by the sensing element. Okay. Next, the sensor gives the output image in voltage waveform. Okay. So the next, the image captured is analog image. Okay. Most of the image captured is an analog image as the output is continuous. Okay, so for digitizing this image, we have to go for sampling and quantization. It means we are going to discretize the image. So here the sampling means discretizing the image spatial coordinates. Okay, so the basic thing is sampling is done to discretize the image spatial coordinates. Okay, so it is with respect to location, it is with respect to the spatial coordinates, whereas the quantization is to discretize the image amplitude values. Okay, so the sampling is to discretize the spatial coordinates, whereas the quantization is to be discretize image amplitude values. Okay, so after completing this image acquisition, we are going to move on to the step image enhancement. Okay, so what is image enhancement? What is image enhancement? It is a manipulation of an image for its specific purpose or objectives. Okay, from the name itself, we can understand we are going to enhance the image. We are going to enhance the image for a specific purpose or based on its objectives. Okay, so mostly the image enhancement are going to be followed in beauty applications. Okay, for example, we can use some filters for image enhancement. We can use filters to minimize the noise in the image. Okay, so especially each filter is used for a specific situation. So the majorly we can use a high pass filter or low pass filter for the image enhancement. Okay, sometimes we can see in our mobile, sometimes we are going to smoothen the image, and sometimes we are going to give some blurring effect, or sometimes we are going to sharpen the images. Okay, so the low pass filter we are going to use is smoothing of images. Okay, whereas the high pass filter is used to sharpen the images. Okay, so this is going to be called as image enhancement. We are going to use some filters to enhance the image for a specific reason. Next one, image restoration. Okay, so the image restoration is also a little bit similar to image enhancement. Okay, it means we are going to improve the image. Okay, but the image restoration is more of an objective step. Okay, so the restoration here we are going to apply to a degraded image. Okay, what we are going to do? We are going to apply it to a degraded image. So the next one, color image processing. Okay, so what is color image processing? Using color. Okay, using color we can classify. We can feel very easy to classify. Okay, for example, the human eye can easily see thousands of colors and shades of black and white. Okay, so for that we are going for color image processing. We are making to feel it very easier. Okay, so it is going to be classified into pseudo color or reduced color processing, the first one, and the second one is about full color processing. In pseudo color processing, that is in the first method, pseudo color processing, the grayscale is going to be applied to only one color, whereas in full color processing, we are going to use full color sensors such as digital cameras or color scanners as a price of full color sensor hardware. Okay, sometimes we can go for color models. The most used models in digital processing, image processing, or RGB model, uh, red green blue model, or a CMY model, cyan magenta, and yellow color, and HSI hue saturation intensity color model. Okay, so mostly the RGB is understandable for RGB is understandable for computer monitors, whereas CMY is understandable for computer printer.